Okay, good morning class. So at this point you got your test back. So we are just going to go through the memo of that class test before we do anything else. I cut this already. Alright, so this was class test 1 of term 2. Okay, I don't know why I'm in the year 2020. Oh, I think this group wrote this class test as well. But I've never seen marks like you guys have before, no? Okay, you guys are a bit special. You guys have some other plan up your sleeve, no? But that's how it goes. We are told in the class test 1, term 2. It's supposed to have been 2022. Given that A, which is x squared plus 4x plus y squared plus 2y equals 4, and B, which is negative x minus 2 whole squared plus y squared equal to 4. The question is determine the center and the radius of A. So for A, we must get it in the form of x minus a squared plus y minus b squared is equal to r squared. So that we can draw the center and the radius from the circle here. So to get it in that form, I'm going to say it's x squared plus 4x plus a number plus y squared plus 2y plus a number equals 4 plus that first number plus the second number. The first number in this case is going to be 4 times a half, which is 2, and it's squared, which is going to give us 4, and 2 times a half, which is 1, and 1 squared is 1. Which now in turn gives us x plus, that's now your perfect square trinomial, which is x plus 2 squared plus y plus 1 squared is equal to 4 plus 4 plus 1 is 9. So the center of the circle is negative 2 and negative 1, whilst your radius is going to be 3. Alright. So we are moving on here. We are then told in 1.2, hence, suppose I've said determine whether or not the given circle touch, intersect, or never crosses each other. That is the case where we have in the circle, the center A is negative 2 and negative 1 with a radius of 3. Whilst the other circle has a center of 2 and 0 and a radius of 2. So if you're looking at the radius 1 plus radius 2 is equal to 3 plus 2, which is 5. Then you determine the distance between the two centers. So AB is equal to the square root of minus 2 minus 2, which is minus 2 and minus 2. Squared plus y, which is negative 1 minus 0 squared. Okay, so that's going to give you negative 4 squared is 8 plus 1 is 9. Square root of 9 is? Did I make a mistake here? Where's my mistake? It's negative 1, it's 2 and 0. So it's going to be minus 2 squared plus negative 1 minus 0 squared. It's 4, 16 plus 1 is 17. Is that correct? Square root of 17. So what do we notice here? We can say that AB, the square root of 16 is 4. So the square root of 17 is less than 5. It's 4 comma something. So AB is less than the distance between the sum of the two radii. And we made a note on this. We said that if the length between the two radiuses were equal to, if the length between the two centers are equal to the sum of the radii, then the surface touches the other ones. If, however, the sum of the radius is greater than the length of between the two centers, then the two circles intersect each other, which means to say they will overlap each other. In other words, they'll cut each other twice. So they will intersect. Okay. Let's look at number 2. In number 2, the diagram below show that RS is the height of the vertical tower T, and Q are 2 points in the same horizontal. T and Q are the two same points. T and Q are 2 points in the same horizontal plane as the foot S of the tower. From point T, the angle of elevation to the top of the tower is 60 degrees. So there is a right angle triangle there. Then we are told that RTQ is going to be theta. Then we are told that RQT is 60 degrees. Then we are told that TQ is equal to K. The question says, express theta in terms of TR in terms of theta and K. TR in terms of theta and K. So looking at TR is this length. TR is in two triangles. It's in that triangle there, and it's in TRQ. Now, of course, we can't work with the first triangle because there's no K and there's no theta in the first triangle highlighted. However, work in the other triangle, in triangle TRQ, we have a triangle looking like this, with that being 60. That's Q, K, T, theta, and R. Okay. So we got many angles, so of course the sine rule. So we're going to be sine of angle R over K. However, I need angle R. So angle R is equal to 180 minus theta plus 60 degrees, or 60 degrees plus theta. I'm not going to say it's going to be 120 minus theta. I'm going to leave it as 180 minus theta plus 60, or 60 plus theta. The reason for that is because I can just apply a reduction formula to it and take it to the quadrants. So the application of the sine rule, oh yes, and that must be called TRQ. No? So there's many angles that are in this diagram. So we're going to say that sine of TRQ, which is 180 minus theta plus 60 over K, is equal to sine of theta or sine of 60, sorry, over TR. If I'm going to go with sine of 60, now sine of theta, then I'm going to end up with RQ. And I don't need RQ, the question was with regards to TR. That's why I have to pick up TR. Make TR the subject of the formula, so TR sine 180 minus takes you to the second quadrant, so sine is positive. Sine theta plus 60 degrees equals K sine 60. I could have replaced sine 60 with root 3 over 2. Okay? So TR is equal to, so that is root 3 over 2K divided by sine theta plus 60. Okay? That's worth 3 marks. 60 plus theta. If you had gone and you expanded it using your compound angles, you would have gotten them all. If you have written that as 3K over 2 sine 3K over 2 sine 60 plus theta, of course you get the mark. Okay. But that is suffice at this point. Then the next question was to show that RS can be written as that. So if RS can be written as that given stored in this. So what I'm going to do is I'm going to take this off here. Just to keep the diagram in focus. So I want to move away from the diagram. Let's look at number 2. Number 2 says show that R is. Now R is, as you can see, it's in this triangle now. Not so? So we're going to say, you've got a triangle looking like this. R is T 60. So we have TR already. So which trigonometric function uses opposite and hypotenuse? Sine. So we say sine 60 equals RS over TR. So I'm going to make cross multiply. So RS is equal to TR sine of 60, which is again root 3 over 2. Okay. But TR is equal to that there. Not so? So there you can say that's root 3 over 2. That is that there. But TR, it's going to be root 3 over 2. That is that part. Okay. Now I'm going to do the sine expansion one time. So sine theta, sine 60 plus theta is going to be sine 60 cos theta plus cos 60 sine theta. Okay, I'm sure that's behind the calculator at this point. Root 3 times root 3 is 3k, which confirms my numerator is in order, over 2 times 2 of course is 4 into sine of 60 is root 3 over 2. Okay, cos of theta plus cos of 60 is half sine theta. So what I'm going to do is I'm going to take a half out as a common factor here, and a half times 4 is 2. So it's 3k over 2 into root 3 cos theta plus sine theta. And that's what they have. Okay? And of course the last question is calculate using that formula there, I'm sure. It says determine the height of the tower. So if you're looking at the height of the tower, in other words, they want you to calculate RS. So RS is the height of the tower. The height of the tower, if it's further given that theta is 100 degrees and k, which is 57 and 5/12. So that's a straightforward substitution question there. So it's going to be RS, sorry. So what I'm calculating, RS is equal to 3 times k, which is 57 and 5/12 meters, over 2 into root 3 cos of 100 degrees plus sine of 100 degrees. Okay, that's now going to give us as a fraction 3 times 57 and 5/12 and 2 open brackets the root of 3 cos 100 plus sine 100. 12,91. 125. 191. And that's how we get 15 marks. Okay. So at this point, let's just take this off here. So as I said, we're going to wrap up chapter 2 on Friday. So please have it marked already. Okay. So for Friday during our maths lesson, we're going to conclude that chapter. Okay. So now we're looking at topic 3. We are told exponential and logarithmic functions. Okay. So in this section of work is basically a revision of exponential laws and functions. All right. This is on what page are we on here? Page 48. You guys can follow in your books. I'll tell you what to highlight as well. Because
your attention please. All netball girls who have their sports clothes with them can please come down to the court for the tennis courts. All netball girls who have their sports clothes with them to please come down to the tennis courts. Lisa Kanya Makiva and Kiara de Villiers, can you please report to the office? Lisa Kanya Makiva and Kiara de Villiers. Please come to the office. Okay.
Basically a definition of exponential functions there. Where y is equal to a to the x, where a is greater than 0, a is not equal to 1. People, this is all grade 11. Okay. So what I want you guys to do is, you will write your key features of exponential functions. You highlight this, you write this in your books. This we have done last year extensively. Okay? At this point you should know how to draw a exponential function. Okay? Exponential graph. We look here, the revision of exponential equations. We've done that extensively last year as well. Sketching the graph shouldn't be a problem. This shouldn't be a problem as well. Okay. So during tomorrow's lesson, I will just look at the examples. Your homework is going to be exercise 1. Okay. So I will go through these examples tomorrow, and then you can just iron out whatever the problems are. Okay. However, for homework, I want you guys to do exercise 1 on page 50. Exercise 1 on page 50. The new work, which is logarithms, will start tomorrow. Okay. People, enjoy the rest of your day. Good morning, class.